Good morning. Today we are going to start a new topic. Actually, yesterday we have completed up to medicinal chemistry, up to I think benzodiazepines, right? So today we will start medicinal chemistry. So let's start. Today medicinal medicinal chemistry. In that we will start drug acting. Already we are completing this topic from yesterday. Drug acting on CNS, that is central nervous system. So can you please tell me what are the different classes of drugs that act on the central nervous system? The most important classes of drugs that act on the central nervous system are: number 1, benzodiazepines. Sorry, you can say sedatives and hypnotics. So let's start from sedatives and hypnotics. Okay, so drugs acting on CNS are: number 1, sedatives and hypnotics; number 2, anti it is also called anti-anxiety drug, anti anxiety anti-anxiety drugs, or it is also called anxiolytic drugs. Okay, number 2, anti-depressant; number 3, psychotic antipsychotic; number 4, after antipsychotic, anti-epileptic drugs, anti-epileptic drugs; number 5, after anti-epileptic drugs, what is that? That is called opioid analgesics, opioid analgesics. Then number 6, antipsychotic, anti-epileptic, opioid analgesic, then anti-alzheimer, anti-alzheimer. Number 7, anti-parkinson, anti-parkinson. Next, number 8, general anesthetics, and number 9, local anesthetics, local anesthetics. Let me fill the marker. Okay, so these are the different types of drugs which mainly act on the central nervous system. What are they? Can you please repeat after me? Sedatives, hypnotics, antidepressant, anti-Parkinson, and please repeat after me, or you can comment below. So these all are the drugs which mainly acts on the central nervous system. Now already we have completed sedatives, hypnotics, short part of the sedatives and hypnotics yesterday. Now today we will continue from that only. So what did we learn about sedative hypnotics yesterday? So sedative and hypnotics are how many classes? They are again of multiple classes. The first one is barbituric acid derivative. Yes or no? First one is barbituric acid derivative. Next, second one is benzodiazepine. Should I write again today also? So in sedatives and hypnotics you will see sedative and hypnotics. Number 1, barbituric acid derivative. Next, number 2, benzodiazepine, that is called BDZ, benzodiazepine and its derivative. Then number 3, pyrazolyl pyrimidine. Number 4, imidazolyl pyrimidine. Next, number 5, cyclopyrrolone. Next, number 6, piperidinone. Next, number 7, EFG. Number 7, pyperizine derivative. Yes or no? Number 7 is piperizine derivative. Next, number 8, parasympatholytics. And number 9, what is number 9? That is carbamate esters. And number 10, serotonin precursor. Right? Number 11, chloral derivative. Yes or no? And number 12 is miscellaneous. Right? Up to this, okay? Now, already we have completed barbituric acid derivative yesterday. Yes or no? That barbituric acid are of 3 types or 4 types. They are long acting barbituric acid, intermediate acting barbituric acid derivative, short acting barbituric acid derivative, and ultra short acting barbituric acid derivative. What is the example of long acting barbituric acid derivative? Example of long acting barbituric derivative is phenobarbital and mefobarbital. Yes or no? What is the structure of phenobarbital? In that you will see everything is having, what is the scaffold? Scaffold is pyrimidine. So this is the pyrimidine. In that 2, 4, 6 oxo रहेगा. Along with that, in the 5th position, one ethyl group will be there. Along with that ethyl group, one phenyl group will be there, and that is called phenobarbital. Then in the case of mefobarbital, that nitrogen will be substituted with methyl group. Yes or no? That is mefobarbital. These two are long acting derivative. Then intermediate acting. So what are the intermediate acting barbituric acid derivative? They are amobarbital and allobarbital. So what is amobarbital? Amobarbital is also called amylobarbital. In that amobarbital you will see 1, 2, 3, 4, 5. So like these carbons will be there, along with that one ethyl group will be there. Yes or no? After that, what in that hydrogen will be there. And then amylobarbital, that is called amylobarbital, that is also called amobarbital. And what is allobarbital? In the case of allobarbital, one allylic group will be there, 2 allylic group. What is allylic group? Like double bond C, Cl. This is allylic group. Yes or no? This is called allyl group. So like this allyl group will be present there. 1, 2 allyl group are present. So this is called allobarbital. Okay. After that, short acting barbiturates. What are the example of short acting barbiturates? Short acting barbiturates are pentobarbital and secobarbital. Then ultra short acting. What is the example of ultra short acting barbiturate? That is thiopental, right? Also I have mentioned that the thiopental is also used as general anesthetics. Thiopental also used as general anesthetics. What is the structure of thiopental? See, again that pyridine ring will be there, yes or no? In that double bond O will be there, double bond O will be there, double bond O will be there. Now in that case what will happen? This will be substituted with S, thio, yes or no? In that one benzene ring, in that something, in the case of thiopental, yes, there 5 carbon was there, 1 2 3 4 5, 1 2 3 4, one ethyl group will be there, along with that one ethyl group will be there, like that. And here nitrogen is connected with hydrogen only, NH, and in that case this S, this is called thio. Like carbonyl group, this is called thiocarbonyl group. Okay, so presence of this will ultimately decrease the activity. It will decrease the activity of barbituric acid or barbiturate. Ultimately it will decrease the activity of sedative, that agent. Now it will act as sedative, not hypnotics. Up to this I think it is clear. Okay, and then what was the general the structural activity relationship of barbituric acid derivative? Structural activity relationship is like, this is the structural scaffold. See, this is the pyrimidine ring, yes or no? This is the pyrimidine ring. In this pyrimidine ring 3 ketone groups are there, and at 5th position 2 hydrogen will be there. Okay, so now what are the 3 conditions possible? Number 1, this ketone group, that oxygen can be substituted with sulfur. The presence of sulfur, what will happen? Thionyl group, thiocarbonyl group, ultimately activity will decrease, and when activity will decrease, it will also act as general anesthesia if we are applying with sulfur. Now the second position, second point, that is second substitution is in the nitrogen, hydrogen is there, right? Now we can substitute that hydrogen with any kind of alkyl group such as CH3. For example, in the case of mephobarbital, CH3 is there, right? So presence or substitution of the presence of this CH3 group or substitution of the hydrogen with the alkyl group will increase the activity. It will increase the activity of barbiturate, right? Next, number 3. What is the number 3 position or substitution that is possible? That is at 5th position. This is the 5th position. 1 2 3 4 5 6. So at 5th position 2 hydrogen was there. If 2 hydrogen are present, this is very less active, very less active. If 2 hydrogen are there, if only 1 hydrogen is there, this is less active. And if there is no hydrogen, instead of hydrogen there is any other alkyl group, then what will happen? Activity will increase, so more active. This is ultimately increase the activity. For example, in the case of phenobarbital and in the case of mephobarbital. Yes or no? Up to this clear? Am I audible or not? Can you please repeat? Can you please text or make a comment whether I am audible or not? Okay, so up to this it was completed yesterday. Now today we will see about benzodiazepine. Today we will see about benzodiazepine. So benzodiazepine is a second class. Today we will see about benzodiazepine. You have to remember that this benzodiazepine is a second class sedative and hypnotics or second generation. So benzodiazepine, it is a second generation sedative, or you can say sedative and hypnotics, that is S and H. Now what are the classification of benzodiazepine? In the earlier we saw there are 4 classes of barbiturate or barbituric acid derivative. In the same way, benzodiazepines are also having 4 classes. Benzodiazepine are also having 4 classes. What are they? Benzodiazepine 1 2 3 4. Number 1 is long acting. Number 2 is intermediate acting. Number 3 is short acting. And number 4 is ultra short acting, right? Number 4 is ultra short acting. Now, what are the example of long acting benzodiazepines? Example of long acting benzodiazepines are diazepam, chlordiazepoxide, next flurazepam, clonazepam. Right? Yes or no? These all are structurally similar, almost similar. You have to change little bit changes will be there, and these little bit changes will make so much changes in pharmacological or therapeutic effect. Okay. Now after that we will see intermediate acting. So what are the intermediate acting benzodiazepines? See, intermediate acting, in intermediate acting IN is there. You just need to turn that IN. Number 1 is NI. So number 1 is nitrazepam, and next alprazolam. Alprazolam is very important for the point of view of GPAT and like different pharmaceutical exams. Why? Because in the alprazolam you will see one triazole ring. That is what is the structure of alprazolam? Simply, this is benzodiazepines. That means it has two structures. One is benzene structure, and this benzene structure is connected with a 7-membered ring, and that 7-membered ring is diazepam. See, dia means two. Diazepam. See, dia as a FM. What does it means? It means that di means 2, aza means 2 nitrogen, F means 7-membered ring, and M means nitrogen group will be present. Yes or no? F means nitrogen group will be present. Am I audible or not? So see, in that case, benzodiazepine, BDZ, benzodiazepine. So see, this is the benzene ring, 2 nitrogen are present, so diaza. Next 1, 2, 3, 4, 5, 6, 7-membered ring, so F, and M means presence of NH2 or presence of NH, like this. Okay, so in that case, this is the structure of benzodiazepine. In this you will see one double bond. In this one OH will be there in the case of short acting. If it is not short acting, then there will be no OH, there is no hydroxy group. In that you will see normal hydrogen only, and this nitrogen is connected with hydrogen again. This is connected with a cyclic structure. Okay, okay na? So in the case of alprazolam, you will see one structure present there. Again, 3 nitrogen containing structure, that is called triazole ring, and that ring is like this. See, that ring is like this. 1 nitrogen, 2 nitrogen, it is connected, and 1 CH3 group there. Okay, again this is having double bond, this is having double bond, like this. Am I clear? So the presence of this triazole ring will make it little bit specific and important for different competitive exam. So simply in the different competitive exam they will ask in which of the following structure 1, 3, 4 triazole ring is present, and what is the answer? Triazole ring. Answer is number 1 is alprazolam, and number 2 is triazolam. If a drug is having triazolam name, then this drug, it is named triazolam because of this triazole ring only. But how many nitrogen are there? 1, 2, that means mono, bi, and tri. Nitrogen means aza, so that's why it is called triazolam. Okay na? So presence of triazole ring is present in triazolam and alprazolam. That's why alprazolam structure is little bit important for the competitive exam purpose. Okay, now we will see the different example of the classes of benzodiazepine. So second one is nitrazepam and alprazolam. Okay, third one is short acting. So what are the short acting benzodiazepines? See, SHORT na. So you will say it salt acting. So salt acting is O. O means oxazepam. O means oxazepam. L means lorazepam. L means lorazepam. And T means temazepam. T means temazepam. Okay. Next, ultra short acting. Ultra short acting only two. Number one is triazolam. And number two is midazolam. Number one is triazolam and number two is midazolam. Now we will see the structure of these drugs. Okay. So before going to see the structure, I think it will be better to see the structural scaffold. That means what is the general structure. So you have to remember one very important point. Barbituric acid derivative are having the scaffold that is called what it is called. Pyri. What it is called? Pyrimidine. It is called pyrimidine. So that pyrimidine ring is present in the case of barbituric acid derivative. But now in the case of benzodiazepine, now I will explain you and I will relate everything. See, in the case of benzodiazepine, you will see one different structure. See, benzo means benzene ring. Now diaza means 2 nitrogen. Ep means 7 membered. In means amino group, NH2 group or any type of group having nitrogen. So 1 nitrogen, 2 nitrogen. Now count the number of members: 1 member, 2 member, 3 member, 4 member, 5 member, 6 member, 7 member. So 7 membered ring, right? That's why it is called Ep. Now this nitrogen will be connected to hydrogen. This nitrogen is having double bond. There will be a cyclic structure present, and this is very important for the activity. One double bond will be present there. Okay. So this is the structural scaffold or basic structure of the benzodiazepine. This is the basic structure of the benzodiazepine, right? Am I clear? Now in that benzodiazepine, you will get how many fragments? The benzene part is the first fragment. This is called fragment 1. That diazepine is second fragment. Diazepine is second fragment, and that benzene ring or any what it is called aromatic group, that is fragment 3. So ring A, ring B, ring C, 3 rings are there. So how many substitution or how many modification are possible? Number 1 modification is there. In that benzene, that is in the 7th position, you will be having one high electronegative group, and that is very much essential or needed for the activity of the benzodiazepine. Okay. So one previous year question was there: which of the following group acts as a strong electron withdrawing group? And the option was chlorine, fluorine, NH2 and NO2. What will be the answer? Strong electron withdrawing group is answer is NO2. Why? Because that NO2 will show minus M effect, that is negative metameric effect, whereas that chlorine, fluorine will show minus I effect, and minus M effect is always heavier or more strength, having more strength than the minus I effect, and that NH2 will be having plus M effect, that is positive metameric effect. Okay, so answer is NO2. Now we will see the structure and what are the modification. So simply you can say that SR, structural activity relationship of benzodiazepine. So this is the general structure. Now in the ring A, first of all we need to number. Start numbering from nitrogen. Why? According to O, S, N, P. Oxygen is having most, then sulfur, then nitrogen, then phosphorus. So here nitrogen is present, then carbon is present. So nitrogen is having more priority to start numbering from. So 1, 2, 3, 4, 5, then 6, 7, 8, 9. So excuse me.